In this community meeting, Joel's going to talk about a new initiative that Joel and the LINBIT development team have been working on. So again, with a kind of mysterious introduction there, I'll pass to Joel to present.
Okay, I hope you can hear me all right. I'm going to tell you a little bit about what's happening with DRBD Proxy. So now that we've just had the announcement of the LinStore GUI becoming open source, I think I can say that this is now the only closed source product provided by LINBIT. There's still one left, and I've been working on it in the last not quite year. And my project has been to rewrite the whole thing in Rust along with help from some other developers. So got some good help from with the others along the way. Why rewrite it in Rust? So there was already a version 3 we wrote in C some time ago, but it uses a very unusual internal architecture, which makes it hard to maintain. It hasn't stood the test of time in terms of maintenance. It's still stable and usable, but yeah, for the future, we want something which we're better able to maintain and use. So now here comes version 4. What is DRBD Proxy about in the first place? So the purpose of DRBD Proxy is to provide stable performance for a DRBD device when it's connected over a network which may have variable bandwidth, so over an internet link, for instance, or over a satellite link, over high latency and unknown variable bandwidth. So how does it help with this? It does buffering, so it just stores some of the data that's going through and sends it out bit by bit. It works alongside protocol A, because if you're using DRBD's protocol C, then DRBD is waiting for a response from the DRBD peer anyway, so don't gain much by having extra buffers. But with protocol A, you can buffer lots of data, and the proxy buffers more than the TCP stack will normally allow you to buffer, and in a more customized way. And the proxy also does compression. So if your data is compressible, which it often is, then you can save on your low bandwidth, make more efficient use of your low bandwidth by compressing it. And this version of the proxy currently supports Z standard, I guess some would call it, version of a compression algorithm. And that's good for many use cases. It's a modern compression algorithm with high performance, fast compression, fast decompression, and a good compression rate for most purposes. So let me show you my screen. Okay, hope you can see my screen okay. So this is a basic sort of context diagram for DRBD proxy. So the proxy is in the middle. DRBD is here. So when you write to DRBD, DRBD sends its data, and instead of sending it to the DRBD peer, it sends it to proxy, but DRBD doesn't know anything about this. It's a sort of transparent proxy as far as DRBD is concerned. So the uncompressed data comes to the proxy, and the proxy then compresses it, buffers it, and compresses it, and sends it out to the other proxy. This is just focused on one instance, but if you had the diagram of the other instance, then here would be another DRBD on the other side. And proxy is controlled by a client, very typical Linux daemon setup with a client program and a service. So that's, I think there's much more to say there. There are always two streams for DRBD connections. Small detail that makes it a little bit more complicated to set up such a proxy, and it always proxies both streams across the network to the proxy peer. So here's the internet, here's the local network. Okay. So now I have a little demo. I hope it's all legible. So what I've got here is, if you see at the bottom here, there's the DRBD status. We've got a node that's just a 2-node setup. This is node 10 and that's node 11, the peer. And we throttled the network to only allow 10 megabytes per second. And then we say, let's write some data. So this just dumps a load of data. Starts quick and then suddenly slows down because even a proxy can't buffer forever. And so stop that now maybe. So now we see on the left-hand side the statistics coming through. So at the beginning, we were able to write to DRBD very quickly because this is filling up the buffer in the proxy. If you have a big system with loads of memory, then you could set the buffer even larger and then take longer to fill up. And then it slows down because we have to wait for some space in the proxy. Here we have the network stats. So this is the loopback interface. I'm running the proxy here on the same machine as DRBD itself. That can also be run on a separate system, but here it's running on the same one. And so we see the data that's written to DRBD is basically the same data that's then sent over the local network immediately. And down here, we see the data that was sent over the remote network. So ETH1 is our external network interface. And that's capped at the 10 megabytes per second that we configured over here. And we can see that we're sending at about that rate for all the time that was being written, and then a bit more, but it's flashing out the buffered data across there. Yes, but if you look at the sort of size under the curve, then you can see how much data was transmitted in total. And you can see that there was more sent over sent locally than was sent over the network. That's the compression. We'll see that a bit more clearly if we just turn up the compression level and write some more, then we'll see a bit more of a difference in terms of the amount of data that's being sent over the network. So yes, here we seem to have reached a almost steady state already. It's getting there. Okay, that looks like it's probably filled up the initial buffers already. So we can see it's able to, even though we can only transmit 10 megabytes a second over the network, we're able to still write 30 megabytes per second to our DRBD device. The data I'm shoveling over here is designed to be sort of partially compressible just for the demo. There we are. Here at the bottom, we can see we've used the CPU pretty effectively, but not completely bottomed out. No, says we haven't completely used the full CPU capabilities. And we can see at the end here again that after the DRBD write stopped, there's still a bit of time sending data over the network. We could do the same thing with a higher compression level and see what happens. Oh, it lost connection. Not very happy. I wonder what happened there. Seems to have reconnected. Maybe the compression level is too high. Let's go for something in between. It's one of those things. As soon as you demo it, then it goes wrong. If you don't demo it, it just works fine. Okay, that seems fine. Possibly we ran out of memory. The higher compression levels do use a certain amount of memory, just yeah, in order to set up various dictionaries and things. And so sometimes with the higher compression level, it suddenly hits memory limits in the VMs. It's possible that it ran into a limit and had to restart. So here we have full CPU usage. And in fact, now we're on a higher compression level, it's spending more time, and its bottleneck is now the CPU. So we're fully utilizing the CPU. We're not even reaching our network level. So this compression level is too high for this use case. It's unnecessary to compress quite that much. Probably the optimal would be somewhere in between. Okay, I think that will do. We could demo what happens if we suddenly have a bit less network and then a bit more, I suppose. Why not? Let's try that for a few seconds, and then the network bandwidth goes up and goes down. Yeah. So we see that despite this loss of network bandwidth for a while, DRBD was still able to write steadily throughout that time period. But eventually, of course, if the network just isn't able to transmit the data, then eventually DRBD will also have to slow down. Oh, just disconnected again. Wow. Okay. So I don't think there's a great deal more to show. We can just continue sending some data. So I will stop there and